All right. Can you hear me okay, Aaron?
I can hear you fine. And you can hear me okay?
Yep.
Excellent.
You're in. Thanks for joining us. Just in the nick of time. It's now 6:30. That may be Jacqueline's computer there making all that noise. So sorry, everyone. Jacqueline, you're coming in with a lot of feedback there. I can't hear you at all. I'm going to have to mute you because it's too loud. There's some sort of feedback happening there. But we're going to go ahead and get started since we're running since it's time to start. I just want to say hello, everyone, and thank you again for attending the Flagstaff Festival of Science Twilight Talks program. My name's Greg, and I'm with the Festival of Science Board of Directors. And joining me here are Jacqueline Salabai, who hopefully we can get her sound working here pretty soon, and Aaron Yazzie, who's here to talk to us tonight about his journey from growing up in Holbrook to working as a mechanical engineer at JPL at NASA's Jet Propulsion Lab. So this event is part of the Flagstaff Festival of Science, which, as you've probably heard before, is the longest continuously running entirely free science festival in the world. We're now in our 32nd year. And so prior to beginning, just a few housekeeping items. We'd like you to know that we are live streaming this via this Zoom webinar via YouTube. And I want to make sure that that's actually started. It says we're recording. And so if you're registered for the event and logged into the Zoom webinar, you'll be able to post questions for our speaker in the Q&A box. And then we'll read questions to him at the end. Or you can follow along on YouTube. And that goes for all of our live streamed events that are going on this week. And so you can find all those events at our website, scifest.org. And so after this presentation, there'll be time for questions and time hopefully to fill out a feedback survey. So Jacqueline, are you able to, is your sound working?
Let me know if it's working good.
Yes, that sounds good. So
Okay.
Jacqueline would like to introduce Aaron, and then we'll get started.
Yes, we are happy to have Aaron here today. I am going to pull up his bio. So Aaron Yazzie, he is a mechanical engineer at NASA Jet Propulsion Laboratory in Pasadena, California, where he designs mechanical systems for NASA's robotic space research missions. His most extensive contributions have been for missions to the planet Mars, which includes roles on the Mars Science Laboratory Curiosity rover, the InSight Mars lander, and most recently, the Mars 2020 Perseverance Rover, which landed successfully on Mars in February of 2021. Yazzie is the Navajo of the Salt Clan Ashiya and born for the Bitterwater Clan, Twitchini Clan. He was born in Tuba City, Arizona on the Navajo Nation and was raised in Holbrook, Arizona. He attended Stanford University, where he earned a Bachelor's of Science degree in Mechanical Engineering in 2008. Yazzie is passionate about STEM outreach and works to increase and improve the representation of Indigenous peoples in the STEM fields. In 2016, Yazzie was honored by the Navajo Nation Council for serving as an inspiration to Diné youth and citizens. And in 2019, received the NASA JPL Bruce Murray Award for outstanding and consistent dedication in promoting inclusion and excitement in science and education, especially among Indigenous communities. This year, Yazzie will be receiving the 2021 Technical Excellence Award from the American Indian Science and Engineering Society for his contributions to the development of the Perseverance Rover's rock sample collection system. And with that, we will turn it over to Mr. Yazzie.
Oh, thank you so much for that introduction. And thank you both for inviting me to be with all of you guys today. I think in any normal circumstances, I might be able to be there in person. And I'm from Northern Arizona originally. I grew up in Holbrook, which is not very far from Flagstaff. Flagstaff definitely was the hub where we would go to pick up things from Target or go to the mall, because our small town didn't have those things. So I feel like Flagstaff is also like my home, also my second home. And ever now I currently live in Los Angeles, California, specifically Pasadena, and that's where I'm calling you from right now. And I've been living here for the past 13 years, working as a mechanical engineer for NASA Jet Propulsion Laboratory. NASA JPL is one of the 10 NASA centers that are located around the US. Our specific center is known for, or our emphasis is on robotic space exploration. So that's why a lot of our missions, since they're robotic, can go pretty like to far distant planets. And so they've sent things to Jupiter and Saturn and to asteroids, and even exited our universe or our solar system. And we've also been the ones that have been responsible for a lot of the Mars missions. And I've been lucky in my career to be able to work on a few of those Mars missions. And I'll be talking to you guys today about the most recent one that we sent, which has been really exciting for us because it's all happening right now. It has just gotten to Mars, and it's been doing a wonderful job on its mission so far. And that's the Perseverance mission, the rover that we just landed on Mars in February of this year. So I've been working on it for the past about 5 or 6 years or so. And it's just a really exciting time for us because we're seeing all of it actually start to perform and doing the things that we designed it to do. And so I have a bunch of slides to show you. Once I get through with that, then I definitely want to take some questions. So let me, I guess first, let me pause and just do another introduction in my own language, the Navajo language. Yazzie Ashihenishle, Turchitni Bashichin, Kiane Deshe, Tokane Deshanella, Kutago the Netnishle, Arut Isya Kindena Shah, Shamato Shirley Dokiazi, will yeah. So that translates to, my name is Aaron Yazzie. I'm of the Salt clan, which is my mother's clan, born for the Bitterwater clan, which is my father's clan. My mother's father's clan is from the Towering House people, and my father's clan is from the Near the Water people. And I grew up in Holbrook, Arizona, and my parents are Key and Shirley Yazzie, and they still live there in my hometown. So let me start sharing my slides. Aha, there we go. If I click on this, can I get a quick confirmation that you're seeing the slides okay?
Yes, looks good.
Okay, excellent. So I like to start off with a series of pictures like this to bring home a point. So on the picture on the left, you'll see a picture that was taken by the Curiosity rover on Mars in basically the foothills of Gale Crater. That's where it landed, and that's where it has been doing studying the rocks and geology of that area since 2012. The picture on the right is a picture that my older brother took of me standing out near on the Navajo Nation near Tuba City, Arizona. If you've ever driven between Flagstaff and say like Page, Arizona, you'll have driven through this area. You'll see these colored hills. They call it the Painted Desert. And I like seeing these pictures side by side because you can really see the similarities between the two landscapes. The hues and the colors of the hills, also just the way that all the rocks and pebbles are broken down on the ground. Here's another example. The picture on the left is me standing on a little ledge cliff near Lake Powell, Arizona. And then the picture on the right was taken once again by the Curiosity rover of Vera Rubin Ridge on Mars in Gale Crater. You can see the similarities on the layering, the colors of the layers on the rocks and the way that they were formed. It's very likely that this Vera Rubin Ridge was also made of, is also a sandstone, which is what the whole area of Lake Powell is covered in. Here's two more pictures taken in Gale Crater. Distant mesas with rocks on the ground, maybe some sand dunes. And then here's a picture that I took near my grandparents' place, also near Tuba City. You can see it way in the background. You can see the San Francisco peaks of Flagstaff. So I always like to talk about how Mars look so much like northern Arizona, especially the Navajo Nation area. And it's not a coincidence that they look the same. They both came from or derived from rocky planets, from terrestrial planets. Mars and Earth are very related. I like to call them cousins because they have a very similar origin. They developed on a similar timeline over billions of years, and throughout that time, they've developed a core, mantle, crust. Mars developed a landscape on it that looks like our deserts because it's the same forces were used to create all of its landforms. Things like wind erosion, erosion from water, because Mars once was covered in water. And we know that when water flows, it can really carve out certain landscapes and canyons. They have Mars quakes, just like we have earthquakes, and that helps shape the land. And so when we're sending robots to study Mars, we're actually really want to learn more about terrestrial planets in general, which includes our own planet. So we're really trying to study more about terrestrial planets, understand how their geology formed over billions of years, but also understand if there is any life that had developed there, similar to how it did here on Earth. And so we've studied Mars in this fashion for many years now. And here's a sort of a family picture of all the past missions and current missions that are currently on Mars. These are just including the wheeled robots. I didn't put in here the other landers like Phoenix or Insight. So starting down at the bottom, there's the little Sojourner robot. It's about the size of a microwave with wheels. And it was really sent to Mars to prove that we could drive anything on Mars. We had never sent a wheeled robot to Mars, and it successfully performed its mission. It showed that we can drive around on the surface and take pictures. And so they decided to send a bigger robot, the Mars Exploration Rover. They actually sent two of them. They're nicknamed, people call them the twin rovers, and their names are Spirit and Opportunity. They were sent there to look for water. Up to that point, scientists believed that there was a lot of evidence that Mars probably had water on its surface, and so the Mars Exploration Rover was sent there specifically to look for water and verify it, and it succeeded in its mission, and it proved that there was once water all over Mars, giant lakes and waterways, and because there was water there at one point, it meant that there was maybe a slightly warmer climate, and it had maybe a climate that was similar to Earth's in a way. So understanding that the climate and there was water and everything going, those are all sort of the things you need for life to exist there. So the idea came into their heads, let's see if there's more evidence that life could have even existed there. So they sent the Mars Science Laboratory, which is the big robot in the back. It's about the size of a small SUV. It stands about 7 feet tall from the bottom of the wheels to the top of its head, which is the remote sensing mass is its head. And it had the ability to drill into rocks and pull out powder from that rock. And then they sent an entire suite of instruments inside that rover. So it would drop the powder off to those science instruments, and it would study them to see if they could find certain elemental components inside the rocks, to see if there was traces of good climate and maybe possibly other building blocks like carbon is something they know that needs to exist in order for life to thrive in a certain place. And so the Mars Science Laboratory also succeeded in its mission. It found that yes, all of the components that life is needed to exist in the way that we know it and the way that humans know it existed on Mars. And so the final step in that is to actually find that life. We found traces and evidence of all the things making it possible for life to exist there, but we haven't found life itself yet. And so we've sent Mars 2020 just this past year to help do that once and for all. And the way that it's going to do that is going to look for ancient microbial life. So here's an example of what microbial life, an ancient form of microbial life, was here on Earth. It's stromatolites that were growing in the bottom of bodies of water. These are just like simple organisms. They're not things with brains and toes. This is the kind of early life that formed on Earth first. It's the first form of life that we were able to find, and the evidence that we have of it is that we have certain fossils, which is that top right picture, that we found that we can date back to the very early development of life on Earth. And so what we're hoping, the way we're going to study Mars in a similar way to how geologists study Earth here, is we're going to try to take some rock cores. If we can drill into a rock and pull out a nice preserved piece of a rock core, we'll be able to date back all of the layers, and all of the chemical elemental components of that rock have been preserved over billions of years inside that rock. And maybe one of those layers might contain some sort of fossilized ancient microbial stromatolite or something like that. And so that's the kind of life that we're looking for when we're studying, when we say we're looking for life on Mars. And so the place that we sent it to on Mars is this area called Jezero crater. It looks like the picture on the right, sort of dried out, big giant bowl that was created by a meteor impact, similar to Meteor Crater near Flagstaff. And at one point, they think that this big crater got filled in with water and created a giant lake. And so this ancient lake also had a river sort of flowing in one end of it. You can kind of see in the very corner where the green circle is pointing, there's sort of like a little, what you could imagine is maybe a little canyon or a wash that flows right into that lake and creates a voluvial fan at the base of that lake. And so that's kind of the perfect location for us to send our rover, because whatever those ancient microbial life forms that might have been growing could have formed in the bottom of this old lake. And at the same time, there's possibly more information that we can get from that river that was flowing in and depositing all this new sediments at the base of that lake. So that's where we sent the rover. And like I said, we want to get a rock core. And how are we going to do that? We're going to send a giant drill with this rover that we're going to use to drill into rocks and pull out rock cores. And this is the part of the mission that I actually got to work on. I worked very closely with the team that built the coring drill, but I was in charge of all the drill bits that it was going to use to drill into the rocks. And we had 3 different types of drill bits that allowed us to do 3 different types of sampling. So one of them is a coring bit. That's the picture on the far left. Drills into a rock and pulls out a rock core that actually ends up being about the size of a piece of chalk. So it's a pretty small little piece of Mars rock. So I think it's about 1/2 inch in diameter and maybe about 2.5 inches in length. And those are going to get saved inside the rover. And we actually hoped to bring those rock samples back to Earth, so that we can study them here with all the powerful equipment and the minds that we have here on Earth. Another kind of sample that we can grab, we will be using what's called a regolith bit. Regolith is basically loose rocky material or sand. So we can stick that bit into a sand dune and move it around and collect a amount of sand, and we can also bring that back. And the third kind of drill bit that we can use is called an abrading bit. And it makes a shallow round abrasion that's maybe about 2 to 3 inches in diameter. And we only go down maybe about 5 millimeters or so. And it's really just to remove that top layer of the rock that has been weathered over billions of years. Maybe it's red from oxidation and rusty, that rust colored red. So we want to get below that layer so we can study the protected material underneath it. And so we can use the different science instruments that are on the cameras that we have on the end of the rover's arm to take really close-up detailed pictures of those abrasions. And so here's me and my team. Where the picture on the top left is us in our extremely clean room, posing in front of the full set of bits that we had just finished building and we're getting ready to deliver to the rover. So these are all 9 of these bits are currently on the rover right now. And we're just so proud. You can't tell that we're smiling ear to ear because we're completely covered. It was necessary for us to take a bunch of precautions when we were building these parts because they're actually getting samples that we're going to use to look for life on another planet. And we didn't want to accidentally send some kind of our own DNA or a piece of our hair or a piece of skin, or we didn't want to drool on it. We didn't want our pet's hair to get on it. So we had to be very careful about how we handled these parts. We had to cover ourselves, always use very sterile tools and sterile gloves. So it was interesting. It was a new building something this clean was something new for our lab. And so that was a total challenge for us and our team. If you look at the tall one here on the far left is the regolith bit, and then the 6 coring bits are next to it. Those are actually hollow on the inside. And so there's a cross section here on the bottom that you can see. They're hollow so that we can insert a sample tube into them. And the sample tube is what you see, that white and gold part floating in the middle there. That sample tube is what actually is going to hold and preserve our sample. So we put one of those inside of our bit when we're ready to use it. We drill, the sample gets deposited right inside of that sample tube, and then we move that into the rover. And the rover has an entire system inside that is basically it's taking pictures and taking assessments of what we collected, and then it'll seal it up with a hermetic seal, and that'll keep it protected while it's on Mars and until we can get it back on Earth. The bottom picture shows a couple of the different types of rocks that we have tested. And these are similar to the rocks that we expect to encounter on Mars. There's some mudstones and some sandstones and some basalts, some volcanic type rocks. And they all kind of vary in how soft they are to very hard rocks. And we have to be able to adapt our drilling parameters in order to be able to collect all these different types of soft or hard materials. The component that's inside the rover that I said is where we store the tubes and where we seal it and all that stuff. That's what's shown here. This is called the adaptive caching assembly, another giant robotic assembly. And you can see, you can kind of see there's a whole bunch of little spaces, the round spaces here. Those are all the storage locations for tubes. And then we have a big arm, robotic arm, that moves these tubes to different stations. So it can pick it up from its storage location, move it into a bit inside the bit carousel, and then we use it to drill, and then they can take it back out of the bit and they can move it over to the vision station and get some pictures of it. They can take it over to the volume station and get a volume estimate of how much we picked up. And then they take it to the sealing station and they seal it up, and then they move it back to its storage location. So that's this big robotic system inside the rover that helps us sort all these samples out. And here's just some pictures I took of the development of the bits. I got to see them from the very beginning stages, cutting metal all the way until the final sampling to make sure that they were clean enough to install on the rover. And so you can see here, we're brazing teeth into the top of it. They're tungsten carbide teeth are very hard, and they can eat through a lot of tough rock material. And the base of that bit is made out of a stainless steel that we heat treat to make it even harder. I think this middle picture is the teeth getting grind into their final shape. These middle pictures are showing the bits getting coated. First preparation for coating and then final coating with titanium nitride. That's that gold color there. Here's our regolith bits getting titanium nitride coated. This picture here is us, you can see 3 gold bits being installed inside this little canister. That's a test that we did where we would take this chamber very cold and spin each of the drill bits and measure how much torque loss there was at different temperatures to make sure that they were going to be fine at really cold Mars temperatures. There's a whole bunch of sampling that went along to make sure that they were clean throughout the entire process. And the bottom right picture is the final installation of each of those bits into the bit carousel before it went onto the rover. So meanwhile, while we're over building the coring drill and all of the drill bits, there's all these other teams that are building all the rest of the rover. So there's a team building the mast and the wheels and the arm and the body of the rover. So all of this comes together in this giant clean room that we call the high bay. And that's the first time that we can finally see the rover come together into its full form. And then just before we have to ship it off to Florida for launch, we fold it up inside of its cruise stage. So this whole shell here is what it travels to Mars in. And one thing I want to point out in this bottom left picture, what we're looking at is the bottom side of the rover, the belly of the rover. And there's a gold plate there, and there's something mounted to that plate. That thing is actually a helicopter. we sent a helicopter with this rover. Its name is Ingenuity, and it's really just at this point, it's a flight demonstration. Just like I said, we had sent rovers to just verify that we could even drive something on Mars. Well, this one's really just being sent to prove that we can fly things on Mars. And flying things on Mars is pretty difficult. Mars has a very thin atmosphere. It makes flying things hard, but it also, like, whenever we're trying to land something there, trying to slow it down from blazing through space at thousands of miles per hour, it's hard to slow it down when there's not enough density of air to push against. So this was definitely an interesting experiment, and I'll show you some pictures of the success of this little robot. All right, so Perseverance launched successfully on July 30th of last year. You'll notice that that was right in the middle of the pandemic. We had to continue working around the clock to make sure that we didn't miss our launch date. And the reason why we couldn't miss it is because basically we can't change the way that the planets are orbiting around the sun. So Earth goes around the sun in 1 Earth year. Mars goes around the sun in about 2 Earth years. It's almost exactly matches up that way. So that means that every 2 years, Mars and Earth will come pretty close to each other in their orbits. And that's the point that we want to launch things between those 2 planets. It uses a lot less fuel and a lot less time to travel there. If we miss that window of opportunity, we have to wait another 2 years before we can launch again. And that can mean, that can make or break a mission. Maybe we don't have enough funding for that. And so we had to make that window, and that meant continuing to work through the pandemic, which was quite a challenge. But we made our launch date, and Perseverance successfully landed on Mars in February of this year. I don't know if you've been able to see the videos or anything of it, but it was pretty incredible. It's always the most challenging part of the mission, because like I said, it's got a very thin atmosphere, and we have an entire landing sequence that is all automated, that all has to happen on its own without human interaction in a matter of, I think it's 7 minutes from the time it enters the top of the atmosphere until the wheels touch down on the ground. And so you can sort of see the steps laid out here. We come in with our heat shield, which protects us when we're entering the atmosphere, because once we start experiencing any atmosphere, there's a bunch of particles that are blowing against the front of your spacecraft, and that'll cause a lot of friction, and that heats it up to a whole lot. And so if we didn't have a heat shield there, we would just burn up our rover. So we have that shield there to protect it. We get inside the atmosphere and we deploy a giant parachute. This parachute will slow us down a lot, but it can't slow us down to the point that we can safely land, because there's not enough air density. So we release the front of the heat shield, and this allows the rover, which is still tucked inside there, to finally see the ground. And it actually has, this rover had some artificial intelligence built into it called terrain relative navigation, to actually look at the ground that was beneath it, compare it to maps that were already loaded into its system, and figure out the safest place that it wanted to land. So it could find the safest place to land and actually divert itself there. So once the eyes are open and it can do that, then that's when we release the rover from the parachute. And the rover free falls for just a split second before the powered rockets turn on. And it kind of acts like a big jetpack, essentially. And these rockets are the thing that actually that will actually slow it down the most, and will allow the rover to divert to the safe landing location, and slowly lower it down to the ground. We can't use this stage to go all the way to the ground, because those rocket motors will just kick up way too much dust and too much dirt, and it might damage the rover. So they actually stop they stop about 70 feet above the surface, and they lower from that powered rocket stage. They lower the rover down on cables on what we call the sky crane until the wheels just touch the ground, and then they cut those cables, and that powered jetpack stage can fly away, so it won't crash into the rover, and then the rover is sitting safely on the surface of Mars. So that whole sequence that I just described has to happen in 7 minutes, automatically. And by the time that all of it happens, the signal will still be traveling to us. So we won't know if it's successful or not until after it's already done. But thankfully everything went well and we had a successful landing. It was a really exciting day. I actually got to be part of JPL's media outreach for that day. There was the TV program Nova was following me that day, and they caught me saying, I was actually sitting right here in this location in my living room watching remotely with my team, and we were all just all of us were separate. Because of COVID, we couldn't be in the same room with each other, and so they caught me saying that I just wanted to hug somebody as I'm celebrating by myself in my apartment. But it was such a really great day, and because of that, we got some amazing footage. So these are just GIF images of some of the video footage that was taken, but you can actually look up online and find these videos and see the real-time video of all of this, each of those steps happening, which is just really cool to see. Once we got to Mars, this was the first picture that it sent back in the top one. It's a little bit grainy there because there's actually a cover on the camera. It's a clear cover meant to just make sure that keep it safe from all the dust. And then they moved those covers out of the way, and then we got a much better picture there at the bottom. And then it started to take a bunch of checkout pictures. Just they wanted to see what the area looked like around us, but they also wanted to get a lot of good pictures of the top of the rover so that we engineers could come take a look at these pictures and inspect it and see if there's anything that might have gotten damaged during landing, and to check everything out. And thankfully, the parts that I had worked on looked like everything was healthy and ready to go. After that, they did a series of more checkouts. The top GIF was them doing their first drive. The bottom one is showing the wheels being wiggled around for the first time, and then they moved the arm around and they moved the turret around just to make sure that all of those motors and those joints were working okay. One of the two of the best pictures I liked that they sent down, the inspection pictures, were the one here. What you're seeing here is the turret. It's basically the big hand that's at the end of the arm with all the science instruments, but it also holds the giant coring drill. And inside that coring drill is we put a bit that we call the launch bit, because it stayed inside during all of launch and cruising and landing, and just protect the insides from any dust or anything, any debris. And so we got to see that bit on Mars. And then this picture on the right is the top of the bit carousel. So all 9 of the bits that I delivered are sitting safely inside of that bit carousel. This is the first selfie that the rover took. The rover is able to take selfies because, I mean, it has a camera at the end of its arm. So they just point it backwards. They take a bunch of, a series of pictures, and then they stitch them all together to get this big one. This one's really cool because they had just dropped off the helicopter so that the helicopter could start its experiment, its first flight mission. And the rover was able to capture a selfie that included the Ingenuity. This is what it looked like when the helicopter was deployed from underneath the rover. And then I think that last part of it was the rover moving out of the way, and this it getting ready for its first flight. And so here it is demonstrating that the rotors are working. And then the bottom picture, it's kind of hard to see. If you look sort of right in the middle, you'll see a little tiny dot start on the ground and then go up and hover above the ground for a little bit and then go back down. So that was essentially its first flight. It was just going to hover and then for a few seconds and then come back down. And so that's the first successful demonstration of powered flight on another planet. And because that was successful, they continued to do more and more flights. This one is such a cool image because you can see this is the helicopter in midair taking a picture of the ground below it. And you can see its little feet at the very sides of the picture. But also in the top corner, the top left corner, you can see there's something there. That little thing is the rover. That's the Perseverance rover. So this is a picture of a flying robot taking picture mid-flight of another driving robot on the planet Mars. It's just insane. And this one's really cool. This is another flight that the helicopter did. This is actually looking down at the ground and taking a video of the shadow being projected on the surface of Mars. So that's a really cool video. So that's all the helicopter stuff. I think to date, the helicopter has done maybe about 9 flights, maybe 10, and it's doing great. It's successful. It's showing that we can possibly fly things on Mars, and maybe that means that they'll end up sending more and more flying missions to Mars. But now we're also getting into a really exciting point in the mission where we're starting to actually use the drill to get samples. And so they moved to this area on Mars, which had a lot of promising rock targets to sample from. And so this is the area that they took their first sample. And here's the first rock abrasion in the top one, in the top picture. Like I was saying, they only drill about 5 millimeters down, and then they actually, because after you're done drilling, there might be dust covering that whole area. They actually use a gas, like basically like pressurized gas, nitrogen, to blow puffs of air onto it to get the dust to flow, to move away from it. So they blow the dust off of it, and then they're able to go in and take some images of it. So that was exciting to see our first abrasion. That's the little abrading bit that I got to deliver with my team. And then we took our first rock core, or our first drilled with our coring bit. The funny thing about the first coring drilled hole that we did, we successfully drilled into the hole. All the parameters were great, but we drilled into a funky rock. The rock was actually what we think was maybe a little bit too porous and had a little bit too many voids in it. And so when we pulled the bit back out of the rock, all of the material didn't stay in a core shape. It kind of just broke up into smaller materials and poured out of the front of the bit. So we didn't actually get a rock core the first time we sampled. But we then found another rock target, which we believed was maybe the less porous, drilled into that, and successfully got our first rock core out of that. And I think you can kind of see here in the bottom picture, it's hard to see, but there's 2 holes in that picture and an abrasion. So this rock right here sort of symbolizes the first time we've successfully been able to sample on Mars and use this equipment that my team has worked on for 5+ years. So it was really exciting for us. It's a really exciting time for us. And I just like to point out, if any of you guys are interested in seeing what the rover's up to, you should definitely go to this website, mars.nasa.gov/Mars 2020. There's always updates going on there, but one of the coolest things you can do is go to the raw images section of that website, and you'll see all the raw images that the rover sends down every day. So right around the time that they send it, and us JPL scientists and engineers get to see it, the public also gets to see it. So you'll see pictures in that area from that the rover just sent down today. So that's a great place to look. And just to, I think this is the latest selfie that the rover took, standing proudly in front of the rock that it just sampled from. So I love this selfie. All right, and then one last thing that I want to bring up about this, a really cool product that came out of this this mission, is that the naming of targets is, we were able to work out that we were going to use the Navajo language to name some science targets, and it came about in an interesting way. So basically what happened is that the science team usually comes up with some kind of theme to identify rock targets just within the team and the science team. And so sometimes in the past they have done things like desert plants, and they'll name different things after different desert plants, and or different bodies of water, or like things like that. And this time they decided that they were going to use the theme of national parks or national monuments. And so they took the landing area of Perseverance, and they split it up into a bunch of little quadrants that were about 1 mile by 1 mile, and they gave each of those little squares a different name that came from a different national monument or national park. So there's like Volcanoes National Park, there's a Yellowstone, but the one that we just happened to land in was named after Cannon de Chelly National Monument. And for those of you that know, Cannon de Chelly is located in Arizona, near Chinle, Arizona, right in the middle of the Navajo Nation. And it's an important place for Navajos. there's a lot of stories, not just cultural stories, but also historical stories. It has some old ancient Anasazi ruins in it. So once the science team realized that there was such a close connection to the Navajo Nation, they reached out to me, and together we reached out to the Navajo Nation president, and to get our three parties got to work together to determine what are some appropriate names, ones that aren't gonna step on any sacred objects or places or items, ones that would be respectful. And so we came up with some names that we were able to apply to different science targets. So here's two examples of them. This top one is a rock that we studied with our SuperCam, which is located on the mast of the rover, and they called it the Yago target, which in Navajo, Yago means like diligent. There's also a certain rocky crop area that was named Seta, which basically means like kind of like sandy area or sand dunes type of area. And then there was here's examples of other names that we were able to assign to things. There's Bidzil, which means strength or strong, Natani, which means leader, Zith, mountain, Natsilid, rainbow, Hahotsa is crater, and Slikan is delicious. And just the last cool thing that happened is that the trivia show, the game show, The Chase, which I think is on ABC, actually used that my name and the fact that we used the Navajo language to name rock science on targets on Mars as one of their trivia questions. And I'm happy to report that the woman got the answer right. So that was just another really cool thing that came out of my time on this mission. Okay, that's all the slides I have. I'm happy to take some questions.
Thanks, Aaron. That was great. That was really great. For those of you who are listening, you can submit questions online. Jacqueline and I see Brandon has joined us now. Might have a few questions for you. I know I do, but I'll let Jacqueline go first if she wants to.
Okay. Just to let you all know that you're able to put your questions into the Q&A, and then we can get those over to Aaron. But first off, I think this question is really good for everyone to see what you're working on next. What are you working on next?
Yeah, so that's a great question because it actually ties in to this whole story of bringing back samples from Mars. So like I was saying, we want to bring those rock cores that we're drilling back to Earth so that we can study them here on Earth. And it's part of an entire campaign that we're calling the Mars Sample Return Campaign. So the Perseverance is the first part of that. The first leg of it is to drill the rocks, get those samples inside tubes, and then save them on Mars. And then step 2 of that is we're going to send a lander to Mars Sample Return Lander, that's going to carry with it another little rover called the Fetch Rover, and it's going to go out and grab those tubes that Perseverance collected and bring them back to this lander. And they're going to pack them inside basically a rocket, and we're going to launch them into orbit around Mars. And so that's the first time that we're ever going to launch anything from Mars into space. And so it'll launch those samples into orbit around Mars, and we'll send a third mission to go intercept those samples that are orbiting Mars and bring them back to Earth. And they'll land, I think they're supposed to land in the deserts of Utah or something like that. But I'm currently working on Mars Sample Return Lander, helping us figure out how we're going to transfer samples from Mars 2020 and the Fetch Rover into the rocket, basically.
Wow, that's amazing. Super amazing. So
Yeah,
we do have a couple of questions.
Yeah, go ahead.
The first question is, it kind of maybe goes into what you were just talking about. What's your next drilling target?
Good question. So I'm not as tuned into decisions of drilling targets as you would think. I've actually moved completely on to my next mission, so I'm not in the room while they're planning that stuff. I do know that they took a small drive from the previous rock target, where they got the 2 cores and the 1 abrasion, and they moved to a new area that's still nearby, and they were able to drill. I think they did another abrasion on that new rock in a new location, and I believe that the plan is to get another core sample from there as well.
There are a couple of related questions. One from Danny McDowell, who wants to know what year you graduated from Holbrook, and there's another question from Joelle Clark, who's curious about your pre-college education experiences. What were some powerful learning experiences you had along your journey? I would add to that, if you had any role models, we'd love to hear about about all that.
Yeah, sure. So yeah, I grew up in Holbrook, Arizona. Did all my schooling there from kindergarten all the way to high school, and graduated in 2004 from Holbrook High School. After that, I went to Stanford. So that jump was kind of a big jump for me, for anybody from that area. But something that really helped me, I think, was while I was in high school, I did a lot of summer programs. So the summer after my freshman year, I did the Najoni Upward Bound program at NAU. I was as a student, was at NAU for, I think, 8 weeks or something, with a bunch of other high school students. And there was a math and science sort of theme overall for that summer. And so it really helped me like explore more of the STEM fields, helped me realize like I'm actually good at this. Like when you're only comparing yourself to your small school, you don't think, I don't know, you kind of don't quite fully understand or what your full capabilities are. But then once I was in the summer program with all these students from all these different schools, and realized that I was still kind of the smart kid, I was still able to do these classes well and stuff. So it really gave me a boost in self-confidence, and helped me come out of my shell a little bit, just meeting all these other kids that were more kind of similar to me. Like we all chose to do something with math and science over our summer instead of anything else. So that was a great program. And then from there, the next summer after that, I went to College Horizons. And that one is geared specifically to introduce Native American students to the college process, or to the college application process and the financial aid application process. And so they bring you up, they bounce around to different sites, different schools, basically. And so I went to this summer program, and it was in St. Louis that year. It's the first time that I ever jumped on a plane, traveled like by myself. So that was just a really cool experience. And I was just with a bunch of really smart natives from around the country for that summer program. And they brought in a bunch of different admissions counselors from schools like Columbia and Stanford and Cornell and Harvard and Yale and Brown, and those people were there teaching us the application process. So it's a really cool summer program. It was the first time that somebody ever told me that I could get into one of those. Like they basically said, like, you should try it because I think you might have a shot at getting into a school like Stanford. So that was the first time that ever entered my mind as a possibility. And so when I came back to school, I remember around the time it was time to apply to schools, I wrote the admissions counselor from Stanford that I met at that College Horizons program. I wrote him a letter. It was the time I didn't even have email at that time. I wrote him a letter and printed it out, put my school picture on it, and then said, hey, I don't know if you remember me. This is what I look like. I think I want to apply to Stanford, but I don't know if I quite know how. Can you help me? And he was really helpful. He sent me a paper application. He was able to get me on board with this visitation program. So I got to see the campus before I applied. So that's really the big reason why I ended up even applying to Stanford was because of that program.
Awesome. Okay. If Jacqueline doesn't have any more questions, I see one more from Sophia Kuzia. She asks, she says, my daughter would like to know if it gets dark on Mars. How long is a day and a night on Mars?
Oh, that's a great question. So just coincidentally, Mars's day is almost the exact same time as Earth's. Mars's day is about 40 minutes longer than Earth. So it's about 24 hours and 40 minutes. So it's almost the same, just not quite. So they actually have a nighttime that's very similar to our nighttime and a daytime that's very similar to our daytime. And our rover will actually go to sleep at night. Like, we actually don't operate the rover at night usually. One, because we like to be able to take pictures and we need the sun's light to illuminate everything. So that's one reason. And two, it gets really, really cold on Mars, especially when the sun's not showing. So at nighttime on Mars, it gets really, really cold, and we don't want to try to operate mechanisms when it's super cold like that. It can wear down the mechanisms a lot more. There's a lot more chances for parts to get stuck or something to go wrong. So we usually like it to be during the daytime, and sometimes we actually even have to apply heaters, turn on heaters to heat up all the parts before we even start using them. So dealing with Mars's cold atmosphere is something that we always have to worry about.
All right, well, let's see. I don't see any more questions coming in on the chat. I could ask, I have one more. We have plenty of time for questions, so if anybody else has any more questions, let us have it. I have another one I'd like to ask, and this is sort of going back to early days again. What advice would you give to your younger self, or to a young learner who might be interested in pursuing a STEM profession?
Yeah, I like to encourage students to do summer programs, just like I was talking about how I benefited each step of my way. And not only because they actually they gave me information and knowledge, but they actually like helped me to understand my own capabilities, my own like my own self-worth, my own confidence, and all that stuff. Helped me break out of my shell and become more of a leader. And also helped me grow my network. So like when I went to the Najoni Upward Bound program, the people that were running that program continued to stay in touch with us students all throughout high school. And I actually learned from the college counselor at that summer program about College Horizons. So that led me to College Horizons. So like those kinds of connections are great, are things that can come out of getting involved in those kinds of summer programs. And then I forgot to mention the last summer program that I went to in high school was one called NASA SHARP, NASA Summer High School Apprenticeship Research Program. That one I applied to and got into. It wasn't geared towards Native American students. It was just geared towards anybody who was interested in science and engineering. And so that was like another boost in confidence that like out of all the people that applied, I got accepted. And I got to be paired with a graduate student at the University of Michigan, and I lived in Michigan for the summer. And the area that I chose to explore was mechanical engineering, and that's after I finished that summer. I was like, I definitely want to study mechanical engineering when I go to college. Like I really enjoyed what I was doing, and I think that's what I want to be. So those are the things that I think that it can come out of a summer program. So continue to do those, continue to do well in school, and also just always reach out for help if you need it. Like when I went to college, it was a time that I had to learn how to be a good student. Like separate from my small high school, I jumped into this university that is just had an incredible engineering program, but also like I was surrounded by brilliant people that also was the top of each of their schools, and some of those schools were big private schools or in larger areas, and so I had a lot of catching up to do, and learning how to ask for help when I needed it was something that really helped get me through that.
Awesome, thanks, Aaron. A couple more questions have come in. We're going to go back to Mars now. And so I'll throw both of these at you at once. One of the questions is, how big will the Fetch rover be? And the other question is about, are there clouds on Mars, and about the gravity on Mars? Like, how does the rover stay on the surface and not, what's the gravity like on Mars?
Yeah, okay. So first question about the Fetch rover. I mean, currently it's still being designed, and actually we're doing the sample return lander mission in partnership with the European Space Agency, and they're building the rover. So I actually haven't seen too much about that rover, but from what I understand, it's going to be about the same size as the Mars exploration rovers that I showed in the clip, Spirit and Opportunity. So you can imagine them being about the size of, I don't know, like a dining table is the best that I just looked at my dining table and saying, yeah, it's about that big. So yeah, it's much smaller than Perseverance. Then the next question was about, are there clouds on Mars? That is a good question. I want to say that there is, but it's not the types of clouds that we have here on Earth. Whereas our clouds on Earth are usually filled with water. Clouds on Mars will be made of a different gaseous material. Because all the water on Mars has since basically either dried up or possibly is frozen in the poles of Mars. There's not really any sort of like water circulation system. You know, like here we have water that gets evaporated up and goes into the clouds, and then it comes down as rain again, and then the whole cycle starts again. They don't really have that on Mars. But I wish I knew the for certain answer about this, but I think I do remember somebody talking about clouds existing on Mars. It's just not the clouds that we have here.
Yeah, I think I've seen pictures of them.
Yeah.
And the last one was about gravity. Was the gravity like on Mars?
Oh, and gravity, yeah. So Mars has gravity. They have about 1/3 the gravity that we do here on Earth. So that means everything feels lighter there. And the rover definitely isn't going to. It's definitely heavy enough to stay upright. We don't have to worry too much about it tipping over, even though like we're pushing down on the ground and drilling into a rock with some high forces. That's not enough to like lift our rover up or anything like that. So the gravity isn't a huge obstacle for us, and it's good that there is some gravity there so that we have that to use.
All right. Well, we're starting to run out of time. I want to thank everyone for listening, and especially thank Aaron for your wonderful presentation. And there's a lot of comments coming in about how much they appreciate your presentation and just loved it. It was great. So thanks so much. I want to remind everybody to please go online and fill out the survey. After all of the festival events you attend, please let us know your feedback on what you think, and it helps us make the festival better every year. So I think we'll sign off here, and thanks again, Aaron, and let's stay in touch.
Sure will. Thank you so much for having me. It was fun talking to you again.
We appreciate you. Thank you so much, Aaron.
Thank you.